Well, good morning, everybody. First of all, I just want to say thanks to Matt and Andrew for covering for me while I was going on a family vacation. I am back home and looking forward to kind of getting back into regular cadence of providing weather content. Now, I want to bookend today's forecast video with this idea about some sub-seasonal weather forecast model issues, all right? Because I'm going to show you the new long-range European seasonal forecast. This is the weeklies here. We're going to look at the seasonal forecast. It's going to take us all the way into the beginning of winter, all right? But I need you to understand something. As you look at these two maps, I pulled these off the web, back on May 20th, and they were the forecast for June. We need to see how well some of these sub-seasonal models have been doing. Now, as you can see, it was going after some quite dry conditions in the Central Plains, very dry in the Pacific Northwest, and it was quite wet in Bay of Campeche, parts of the Caribbean, and into Mexico, and then wet. I mean, this whole region was forecast wet, and we actually were expecting pretty good moisture to come through parts of the Canadian Prairie. On the temperature side of it, we just had this region in through here that was expected to be hotter than average. So let's just take this for what it is and go see how well it did. Let's talk about the temperature side. So get a good look at this map. Here's the verification. Now, if you remember June, I understand a tremendous amount of weather has already happened in this first 7 days of July. But if you think back to June, we started off the month very hot in the southwest, okay? Very cool in the central United States to the northeast. And then this pattern just flipped, right? We had very cool weather in the northwest as we approached the end of June, and then got really hot here. So this map, which looks at the month of June as on the whole, is not going to be representative of the changes that we saw throughout the month. But the precipitation, you can think of a little bit differently, okay? It's just cumulative precipitation. And what we saw was significant drought pressure build into the northwest, despite some of the cooler weather that came in. It got very, very dry for June standards. And there are places in the northwest that do rely on those late spring, early summer thunderstorms that do come in to help with the hay, with the winter, every crop that we grow in the northwest. But then you look outside of that, and other than coming out of the Canadian Prairie into parts of North Dakota over toward the Red River Valley of the North, we saw very wet conditions overall reported in our climate reporting districts. Now remember, these districts are large. We're averaging across a large domain. So this is not picking up on the spatial variability of the rainfall. But we just need to take it in the whole, because go back to what the forecast was. I mean, this is a pretty aggressive dry forecast right here, and it wasn't there. Now, there are pockets that were dry, but we have to be quite careful when we think about how well these models perform, because I'm about to show them to you again. We're going to look at them. We always look at them. They're information, but we just have to understand context around that information so as to whether or not to know to use it. Does that make sense? All right, so last 7 days, in other words, what's gone on since we started this new month. This is our precipitation map. And I know sometimes it's difficult to see the holes in this. We're going to address those in a few moments. But I want to just take a moment to pick up on the incredibly heavy rainfall that started on the 4th of July, actually the 3rd of July, and went through the 4th of July into the 5th into southern Texas. So I want to focus in here and just give this a moment of discussion or meteorological discussion on this, all right? First of all, what was our main narrative for so much of June? We had this massive and expansive region of the Bermuda High, right? I kept pointing out multiple pieces to it. But back on the 4th of July, the main part of it was sitting right in through here. But we did have another piece that was over there, and we had some of the high pressure that was sitting in through here. And the net effect was we've had very strong trade winds that have been basically advecting or moving moisture through the Caribbean into the Gulf, and it's been coming up into Texas from this direction. This is wide open moisture transport. And there's even a tropical system here ahead of this that saturated parts of Mexico as well. But this is the way the flow looked going into the 4th of July. Now, I went ahead and ran the high split model to get some back trajectories on where the moisture came from into this flooding event, just so you could see how far away we were able to transport and then concentrate that moisture into one area. And this is just a look back to where the source, the streamers, the airflow was coming from. It's from some of the most humid and saturated places in the northern hemisphere in the middle of summer. And there we go. We're just shoving that moisture into this region. If you want to see it compared to average, this is the 27th of June through the 4th of July, looking at something called precipitable water. Now, we've looked at this a lot. The blues would be the cooler colors here would be the dry air. So there's very dry air that moved into here. We actually had some fires that showed up in parts of California as a result of this. And then if we look at where the very humid air, the very moist air is, it was in this corridor. Again, just being pumped into this region like this. In terms of relative humidity, which remember is relative to temperature, you can see we were 25% above average in this area. So sorry, the colors kind of flip-flop on you there, but I want you just to see how humid the air was in this particular region. So yesterday I went over and downloaded all of the radar data every 2 minutes to show you this particular event. And I've compressed basically 2 days worth of radar data into a 30-second video. And the problem with this was where the lift in the atmosphere was being sourced from. It was locally generated from the thunderstorm complexes themselves, and they evolved into what's called the mesoscale convective vortex. Now, many of you have been watching the news, and you've seen these absolutely horrific videos of how quickly the floodwaters came up. And there's been a lot of criticism about the National Weather Service and all sorts of things that, I'll be honest with you, is quite... it's a lot of blaming and finger pointing and whatnot. If you want to know how well the National Weather Service did with this, they put out advance warnings. They actually brought in additional staff. It was an incredibly well-managed event from the prediction side of it. It was the timing that was terrific, and I mean terrific in the bad sense. It was terrifying because when this was happening, look at the times over here. This is the middle of the night. And as this came through, you can just see the mesoscale convective vortex spinning around itself. And even as we got through the day on the 4th of July, watch what happens as we get into the 5th. There were still repeated thunderstorms training, following over the same locations. There it is. Look at this continuing. And as a result of this event coming through parts of Texas, we saw some areas that picked up 16. I think there are going to be a few locations that grabbed as much as 20 inches of rain. And it's hyperlocal. It's falling on an area that does have terrain differences. There's hills here, and that focuses the water very quickly into into the riverbeds. And what we saw unfold was an absolutely tragic disaster. And sometimes you just don't have words for it. And today I have to look at it from a meteorological perspective because the number of lives lost, I still don't know the official total. I think last night I was reading. We were over 70, making this one of the deadliest weather events in recent U.S. history. And it's just absolutely tragic. But this has been the way the atmosphere has been behaving this entire spring and summer. Highly regional, major not discrepancies, what's the right word, like range in precipitation. I keep using the word disparity. You go from one spot that's got nothing to a spot that's got a tremendous amount of rainfall. And we've seen that time in and time out. I don't expect it to quit. I really don't. And while that was going on, if you just look back over the last 3 days, so this was made this morning at 6 a.m., go back over the last 3 days, we also had a tropical system. It was Tropical Depression 3, got the name Chantal, and it went through parts of the southeast. And we can just take a look here. There's some locally very heavy rain in parts of Georgia, South Carolina, and then right into this corridor, North Carolina, where there was more flooding, just from the fact that the way that the tropical system sat and kind of spun over that area, we just continued to put heavy rainfall down in this region. That's just to pick out a couple of spots, okay? If we look at the broader scale view of this is where the tropical system was sitting yesterday afternoon toward the evening. The other component to this was this region right in through here saw a front come through. And this was some of the first in a long time rain to hit this particular part of the Midwest. There continued to be large, isolated storms that ran up and down the Front Range of the Rockies. Yet you get out into the plains and many of the areas were missed, except a few of these regions, which some of these storms put down a lot of hail yesterday as well. As you continue to play this forward, as sun is setting, we can see some wildfire smoke. These are from Canadian wildfires here, but there was also some wildfires that were going on in Northern California. I was keeping a close eye on those just to kind of watch as heat builds back into this region. I mean, we can see, again, some of the wildfire smoke here. But one of the kind of broader areas where there are much larger fires comparatively comes back into parts of Manitoba. So you get up here in north of Lake Winnipeg and you start to see these very large fires getting just blown by very strong winds. And that wildfire smoke continues to mix into the lower atmosphere. As we watch the forecast of where that wildfire smoke is expected to go over the next 48 hours, we can see more still in the west. You can see the wildfire smoke spreading out of parts of Manitoba into Ontario, coming through parts of the Great Lakes states. But this is going to be a more common topic to be discussing over the next 2 to 3 months as we get into fire season for parts of North America, specifically the western part of North America. All right, big picture, where's it going? Well, I want to show you 3 different forecast models for the next 14 days. And remember, this is wetter than average and this is drier. And this is the European model forecast. We've already struggled with significant drought pressure across parts of the Canadian prairie. There was some relief, what was that, 2 weeks ago that came through here, but if we do see this continue to get hot and dry, this is going to be an issue. I know you see dry conditions along the Front Range, but the models are unable to pick up on the daily convective events that hit the Front Range, but I'm concerned about the high plains going over drier. Maybe parts of the Midwest, surrounding maybe Michigan. That's an area that we need to focus on. While it's going to be quite wet through parts of the Mid-Atlantic, we still see a lot of storms in the midsection of the country. Now, that's the European model forecast. Here's the GFS ensemble next 14 days, and you can see some similarities. Some of the differences we need to have a discussion about. We'll be doing that all week. But the AI forecast model's got a very interesting kind of attribute to it. And I'll be honest with you, the AI forecast model, I don't tend to look at its precipitation product very often. One, it's very low resolution. Two, it does not pick up on convection very well. It's using historical information, right, to make these forecasts. But I'm curious about this band in through here that's showing up drier. That's something I want to be watching over the next couple of weeks. Now, thinking this through, what do we need to be paying attention to? It's summer. And when it comes to summer, I'm looking for long waves. I'm looking for low momentum. I'm looking for positional strength of like Bermuda High, Pacific High. So let's do this. Let's pull up momentum first. There it is. And let's take a look at where momentum is. It's still low. Now, I told you that the biggest risk for major drought development in the central U.S. is if this just continued to plummet. And since it's kind of come back up a little bit. All right. Now, this is global momentum. Some of it's being contributed from the southern hemisphere. But if this area expands into the future, we do see a much longer wave pattern that could be creating broader scale high pressure systems that potentially produce some drought somewhere. That's something to think about for the hardest summer. But those pressure systems right now are here. So here you go. Bermuda High. Remember, we typically look for it to live between the Azores and Bermuda, so it's got to be in this area. And I just watched this region. See the high there? As I play forward with the European model, all the way through Wednesday, Thursday, Friday. Where's the Bermuda High? It's here. And as we go forward, this is Friday, Saturday, Sunday, getting out to next week, next Tuesday, Wednesday, Thursday, Friday. We're just keeping going through the next 2 weeks. And during that time frame, the Bermuda High is generally speaking somewhere in this area. Now, if the Bermuda High drifted here or was way over in Europe, we'd be talking about something entirely different. But it's not overall moving away from its typical domain. We need to talk about size and strength. That's going to be important. But the fact that it's not drifted away from this spot yet is really what is, well, to be honest with you, is why we're keeping these, there they go, these forecasts with storms in places. We're not seeing forecasts that go over very dry in the midsection of the country to the east. So what about the west? Well, the west is going to come down to the monitoring the position of the Pacific High. We look at this, the flow over the top of it, where the big ridges and it's all a part of the same system. But just watch. Here's the Pacific High. As I play it forward, it at times creeps toward the northwest. But look at this. See this flow coming in through here? This is pushing a lot of warm water that's here into the Gulf of Alaska. Keep that in the back of your mind because I'm going to talk to you more about that in just a few moments. But overall, I do see this encroaching into the Gulf of Alaska, the northeast Pacific getting toward the Pacific Northwest here, which is going to be important for their temperature pattern. But that Pacific High, it's staying in the Pacific. So what does this all mean? It means this. This is something I do like the AI FS model for. It tends to pick up on the pattern well. So the Pacific High is living there. There's a trough of low pressure here. And the Bermuda High, well, it's a near surface feature, but there seems to be higher pressure there. Take note of what's going on in the wave train downstream. What have we lost? For weeks, there was a deep area of low pressure here. It's gone. So now we've got this. Oops, sorry. Let's try that again. We've got this. Highly amplified pattern, but a trough in Central Europe. That's breaking a major drought there. I'll address more about that in a few moments. But do you say, Eric, if you see this pattern, what does this mean? This means I would tell you that the West probably going to see more episodes of heat, and it's going to be drier. But coming over the top of that ridge, we're going to get storm complexes that are going to roll through here, and they're going to have access to Gulf moisture. It's probably going to be hotter in the Northeast, but in the midsection of the country, not so much. Now, why this is so important is because of some of these forecasts that have been released. And I know a lot of us like to look at the National Weather Service forecast, and I imagine they're going to make some changes to this today, because this was their forecast from yesterday. Look at the 6 to 10 day and the day 8 through 14. See how warm they were? We'll talk more about precip in a second. See how warm they were. Well, when I think about this is context. We have to remember that getting hot at this time of year can be a major issue. And we know, we looked at this last week, this was how the end of June and beginning of July is shaped up. Very, very hot conditions here. And this is, by the way, the low temperatures. We've had very, very warm nights in this area. Now, why this is so critical is because we can accumulate heat on the daytime max side or the overnight low side, and that can be detrimental to the crop success. On the daytime maximum temperature side, the total number of stress degree days that have been accumulated so far this year, we're starting to flirt with some numbers that we need to pay attention to. For example, just outside of Chicago, we've already hit 101 of these stress degree days here. And this is a drier area, except for some of the recent storms that just hit it, which have been absolutely life-saving for the crop in this region. But as these numbers begin to approach 100 to 150, we tend to see some stress. Now, just take a look. Now, I'm only showing you the Midwest because the research on the stress degree days has been applied to a corn crop that's primarily in the I-states and surrounding areas. So what I'm trying to do here is say, all right, if the forecast is as hot as suggested here for week 2, that's going to be important. But I mentioned, I think they're going to change this later today. And the reason for that is here. New models came out, and we just continue to see that the position of that trough is going to influence over the next 10 to 15 days a pattern that's hotter on the corners here and here with cooler weather into the midsection of the country. As I just played out, that seems to be the way this is all coming together. So this is like the prime time, and Matt addressed this last week. I mean, for the midsection of the country, especially if you're growing corn, this is pollination through June. This is through July 22nd, and we are not seeing long duration hot episodes. It's still summer, it's still hot, but there's a big difference if I'm in Iowa and it's 90 versus 98, or the overnight lows being 68 versus 74. And those are the kind of differences we're talking about. This is not spreading in the excessive heat into those areas. So I'll be interested to see how the National Weather Service updates their map later on today, which they will. They're probably going to follow the same trend that I just kind of showed you. Okay, with all that being said, let's get into what we're dealing with right now. We do have heat advisories that are in place here. And here there's excessive heat watches and warnings that are down in the southwest. The flood watches and flood warnings remain for parts of Texas. If you have a look at the Storm Prediction Center's next 3 days, here's Monday, Tuesday, and Wednesday. We're going to watch parts of the Central Plains very closely later today where there's an enhanced risk of severe storms. I'd like to show that to you by going to the, let's update that again, the High Resolution Rapid Refresh model. And as we play this forward, this is through the middle of the day today. Look at all the scattered convection in this area. And then watch the storms late this afternoon blow up here. Now, there could be some in parts of South Dakota. Keep an eye here going into Minnesota, but we're going to watch these for large hail, the risk of rotating storms producing tornadoes, and straight-line wind damage. So that's coming out of South Dakota, out of parts of Colorado, getting into Nebraska. And we're going to watch that storm complex late this afternoon and this evening. Now, there will be isolated severe weather events here, okay? But the bigger event, I think, as the models are honing in on it, it's going to be right there in the central U.S. Now, we're going to be using the HRRR, the HRRR, a lot more because of the sunsetting of the high-resolution NAM model that was told to us by NOAA. They're switching their modeling system, their high-resolution modeling systems, which is good. This is a natural evolution of things with NOAA. It's good to see them doing that. So we're going to see a whole lot more of this model in these forecast videos. But bigger picture from the National Weather Service's WPC product, that's the Weather Prediction Center, this is the next 7 days. And I start to see moisture coming in to fuel the southwest monsoon. We see a lot of scattered storm events here. And we see some locally heavy rainfall out of this. Now, thinking this through, I want to let you know something about weather forecast model performance. We look at these all the time. This is from Dr. Ryan Maui. I appreciate him letting me use this. I do want to take note that as of late, starting the month of July, we've had a pretty sizable drop-off in model performance. And the GFS model heading into that historic event that hit Texas was showing skill scores down there around 74%, which is very, very low. Now, the National Weather Service doesn't just use the GFS. They use all of the weather forecast models. So please don't assume that that drop-off was why maybe there wasn't 7 days of advance warning of flooding in Texas. There will never be 7 days of advance warning of flooding in Texas from an individual thunderstorm cluster like that. Hurricanes, yes, but something like this, no. But you need to understand that the model performance has dropped off. I'm going to stick with the European model overall. Let's play it out real quick. This is just starting this morning, going through. Look at the complexes of storms along those two positions we talked about by tonight. This is then getting into Tuesday and Wednesday. And again, we just see big flashes of green where the storms are expected to pop throughout the day. Now, later on this week, onto Friday into Saturday, there's a low that sneaks through. It came over the top of the ridge and it's curled itself up here. And it's going to drag a front late this week. It's Saturday, it'll be here. Widespread storms over the southeast mid-Atlantic into parts of Texas as well. But that front's going to clear things out. See it coming through there? And that's what we're expecting over the weekend. It's going to take the temperatures down with it. And what did you see happening again? Another low rolls through this. So you say, what's the influence of building in a ridge here and a ridge there? Lows form and they go over the kind of through the saddle point into the middle of this as they kind of traverse through. So in terms of precip anomalies, there's the next 5 days. That's through next to 7 days, This is day 4 through 10 as we watch those lows go through. You stitch it all together over the next 10 days and you get this. Okay. Now, probability-wise, this is the chance at grabbing another inch over the next 10 days. And I had an interesting question, that came from a grower while I was on vacation. He says, is it true that, and he was in Iowa, that we need an inch of rain a week to have a really great crop? I'm like, yeah, that'd be ideal. But do you want to know why we say an inch of rain a week for a corn crop is ideal? Well, that's because the typical evaporation rate is about 0.15 to 0.2 inches per day in the middle of summer. So you add that up over 7 days and you're a little bit over an inch. And so you need an inch to replace what evaporates if you want to keep the water system available for the crop. That's where that comes from. But overall, I see the wettest conditions, right? Remember, this is including the remnants of the tropical system here. But can you tell where the Bermuda High is? I mean, look at it pumping in moisture here. There's plenty of moisture that's opening up into this section of the country. Now, I do want to show you who's drier in this. And I know we got a new model running, so this will flip for me real quick. There it goes. Let's go back to the older one. 10 days. There it is. We're watching the west. This is climatologically consistent. It's typically dry here. But I want to keep a close eye on the surge of tropical moisture that's a part of the monsoon that's coming into this area. Again, storms will be on the front range, but we have drier air that's going to be in the higher plains we need to keep an eye out on. So just understand that, plus look in the parts of the Canadian prairie drier too. Now, when we look at the week 2 forecast models, there's quite a bit of difference here. European AI model, and then here's the GEFS. NOAA's forecast, which are going to update again today, they were getting a bit more aggressive with a drier section in through here. I'll be curious to see how they let this evolve given some of the new model evidence we see here. But I'm just going to tell you something. When the Bermuda High, or if the Bermuda High ever leaves, then I'm going to start to take thunderstorms out of the forecast in a big way. Okay, that's where we're going to go. So with that, let's get on to this. I do want to point out, I don't want to let this slip through the cracks. There are numerous locations that did not get these storms. Okay, I mean, just take a look at this map showing the last 7 days of total accumulated precipitation. There are holes, there always are in these forecasts. You look at the map, you're like, wow, it looks like everybody's going to get some rain. No, that's a modeling issue. When it's all said and done, it's still summer, hyperlocal convective events. And I'm specifically thinking about my backyard. I got home from this vacation and we didn't even need to mow because it got so dry during that time frame. And there's a large area that stretches from like near north of St. Louis through parts of, Illinois. Maybe this is like the I-55 corridor here, but it's in Indiana. It's in Michigan. Look at North Dakota, parts of South Dakota, or sections of Kansas. You can find these holes in lots of different places. Now remember, the AHPS product is always a day old. So this was through Sunday morning, and it did rain. I mean, we got some rain. That's my house, 0.42 right there. So we did pick up some moisture from some of the thunderstorms clusters that came through, and they desperately kind of saved some of the crops in these areas. But other places did not hit on some of these storms. I just want to point this out because those areas are really continuing to show up in our soil moisture values. This is the latest look at the top 16 inches, and I got to point that out. There's an area from central Michigan through northern Indiana and Ohio that stretches through Illinois, pockets of Missouri, Nebraska, which we are expecting storms here soon. But the Northwest so dry, pockets of the Canadian Prairie and Northern Plains, sections throughout the Southeast. I mean, you can find these anywhere as you look around the country this time of year. Now, a moment ago, I mentioned, the evaporation rates. And here we are in the middle of summer. We are at kind of the hottest part of the summer for the midsection of the U.S. So these evaporation rates are typical. And 1.3 inches is normal for where I am. So we need to get, about an inch of rain to sustain the crop in a perfect way. But overall, that's your 7-day evaporation rate. Temperatures, 7-day GDDs, this is very common. There's not a whole lot in this that's different from normal. That's how many GDDs we expect to grab in a week. And the stress degree days, this tells you the cooler weather, where it's coming from. Look at this. Look at all these single digits in this area. So to get a stress degree day, you have to have highs over 86. And we're just not expecting that. So Matt mentioned this. This is this cooler stretch of days during pollination, which is going to be critical to the success of the crop. Now, further to the south and southwest, it's really, really hot down there. Take a look at these high temperatures, 111 to Phoenix today, deep into the 90s, triple digits in parts of Oregon and Washington. And then it's hot from parts of, the south and southeast all the way through parts of the northeast. Let's see where it goes on Tuesday, Wednesday. Look at the heat coming into the northern plains, running up and down the front range. Still 117 in Phoenix. That's where the excessive heat warnings are. But that's Thursday into Friday. So look at the cool down we're experiencing here. 100 degrees Wednesday, by Friday back into the 70s. Central Valley of California going up to 102, 105. And by the time we get to Sunday, repeated shots of cooler weather here, more sustained heat in the northwest. Now, I just want to bring you back to what I showed you earlier. There's your next 5 days in terms of temperature anomalies. This is day 5 through 10. And this is day 10 through 15. And this is a key component to what's driving this pattern. Where the Pacific High sits, the flow going over the top of it, and where the next ridge is. And that seems to be the setup as we go into the middle part of this month of July. Now, there's a downstream effect of this, and you saw it earlier, and it's across Europe. After talking to you for weeks about the drought in Europe, we can see that the breakdown of that blocking long wave pattern has resulted in better chances of rain from Spain into France, parts of Germany, but look at Poland. So where are we going drier? Where it was wet, which is here. Temperature-wise, if we just take a look at the temperature anomalies, it's now getting hot where it was cool and cooling where it was hot. This is the pattern progressing and moving. So I just wanted to bring that up before I stretch this out into a longer forecast. Now, a moment ago, do you remember what I told you? Watch where the winds coming through the North Pacific are blowing the very warm water. It's here. And if you heard me speak at all during winter, I told you that if we're going to see major summer drought risk in the midsection of the country, it is very rare for that to happen when there's warm water here. And we just have warm water surging into that region. We also don't have the MJO in the right spot. I mean, the MJO right now is favoring this side of the phase diagram. If it sweeps back around like the European weeklies are suggesting, then okay, then we have risk. But the European weeklies have been doing that for a while. I mean, look at the pressure patterns they're forecasting. Weaker than normal Bermuda High. Okay, that's a red flag. That should shove pieces of it here. That would be a significant problem. It keeps showing that all the time. Yet we don't end up getting what the forecast model suggests. This is the new outlook. Let's just take you out there to the middle. I don't know. There we go. Let's do July 12th through August 12th. And again, it's like, I don't know, watch out for this whole region to be dry. But it missed all of this. It missed this in a big way for the month of June, did it not? So I would just make an adjustment. I do think that there is dry risk here. Matt made a strong case for this last week. I see it. 2006 was an analog that Matt's been discussing. I've been discussing it since January, that we've been discussing it. This is something Matt and I do every day. Seems to be showing up as a possible analog. But just take a look at the 30-day temperature pattern out of this as well. And I'm just going to tell you something. Take this with a pretty large grain of salt, okay? So what's the longer term? I told you we're going to bookend this with a longer term forecast. The newest update from NOAA just came, not NOAA, the ECMWF just came out. Got to get back on my game after vacation here. And it's plumes for predicting the ocean temperatures in Niña region 3.4. That's the middle of the Pacific along the equator. It's actually got a better chance of negative INSO, that's a weak La Niña, through fall into winter, which will definitely impact the hurricane season. But I just want to show you what it's currently going after. I mean, this is the new July, August, September outlook. Now, the European model has said July and August and September are going to look something like this. We're going to be watching for homegrown tropical systems in the Gulf and off the southeast coast. We're looking at a more active southwest monsoon. We're looking at wetter than normal conditions in the northwest, and it's trying to just plant dryness in the Canadian prairie down into the Midwest, Great Lakes. But the model's been attempting to do this for a long time, and yet we've not seen the precipitation anomalies happen like this. But let's keep going. This is now August, September, October. Look at this. Potential for homegrown tropical systems. This is September, October, November. And then going into a La Niña fall and La Niña winter, potentially. That's what it's got all the way up for the November, December, January. Now we're just looking at this. This is not, I almost said this is not real. It's real, but it's not accurate. It's not skillful. We're just having an idea what some of the forecast models are putting together. In the near term, can I just bring you back to something here? I do think we do need to be on the lookout for this region to struggle with drought development, with isolated drought issues here. It makes sense to say an active southwest monsoon's coming through, and because the Bermuda High has been just so readily pumping Gulf moisture into the southeast, I do think that that's a risk of staying wetter there. I think that, again, isolated pockets of drought developing, but until we see just here it is again, a major loss of momentum, or the Bermuda High or Pacific High drifting away, I don't know where major drought scare is going to come into the midsection of the country to the East Coast. I'd also just tell you that I know you see a lot of red over here, but I'll tell you that there are waves of cooler weather coming through, especially in the next 2 weeks. Now, this is week 3, week 4, but it's just something to kind of assess. All right, taking enough of your Monday. We'll talk again tomorrow. Matt will pick this up, and throughout this week, we're going to build a narrative into the why for this subseasonal forecast for you. All right, have a good one. Thanks.